Covalent bond in carbon. Generally, for the formation of a chemical bond, a pair of electrons is needed. Let us consider the hydrogen atom. Hydrogen has got its own electron here, and this hydrogen has its own electron. When these two hydrogen atoms they approach each other, what happens? There is a common overlapping of electron. So this leads to bonding, and in this case, this is a mutual sharing of electron. So it is called covalent bond. So this is the case with hydrogen. So it is simply represented by H, that is bond between hydrogen and another hydrogen. So that gives rise to the H2 molecule. So covalency is the equal combining power of atoms. That is called covalency. So first of all, we should know what is valency. Valency means the combining capacity of an element, of an atom. So it is also the number of electrons available in the outermost shell or orbit for bonding. So covalency, as I already mentioned, it is the equal combining power of atoms. So what is covalency? It is the equal combining power of atoms. So a covalent bond is formed by mutual sharing of electrons. So in the case of chlorine, each chlorine atom has shared one electron. For instance, a chlorine and chlorine. So this chlorine has an atom electron and this chlorine has its own electron. Say they combine together to form what? A bond. So it is represented as Cl. So we call it chlorine molecule. So this bond is called covalent bond. So chlorine covalent bond. And in the case of hydrogen, let us look at it in detail. A covalent bond can be formed by combining these two hydrogens. These two hydrogens are at distance. When they combine like this, it forms a bond. So it looks like this. So this is H2. Similarly, chlorine as atom. When they combine together, it forms a chlorine molecule. Let us consider methane. So methane is represented as CH4. It means one carbon and four hydrogen. Four hydrogen. So they are formed like this. So they can simply be represented as CH4. So how many CH bonds are there? 1, 2, 3, 4. So there are 4 CH bonds, covalent bond. Understand? So that leads to a molecule like this, and you cannot imagine like that is symmetrically they combine in this way. So they have their own shape, and this shape is called tetrahedral shape. So it is called tetrahedral structure of methane. So after the combination, it will be like this. So for a better understanding, we have pushed this hydrogen away from this carbon and made as a molecule like this. So methane molecule. Okay, and the simple representation can be in this way. You understand? Right. Then in the case of ethane, so ethane is represented as CH3 bond CH3. So it means previously it was like ethane, methane only. So in place of one hydrogen, one methyl group has joined. So it has become, I have removed one hydrogen. In that place, I have introduced another methyl group. So this is called ethane. So it is structurally represented like this. And we must ensure that always the valency of carbon should be satisfied. What is the valency of carbon? It is 4. So you must ensure it should have 4 bonds around each carbon. 1, 2, 3, 4, 1, 2, 3, 4. Now can you identify the type of covalent bond? There are 6 CH bonds here. Is it not? 1, 2, 3, 4, 5, 6. And there is one CC bond. So this is different, CC bond. Okay, so this is CC bond. So likewise, we have 2 types of bonds. And you should know something about double covalent bond also. This is possible in the case of ethene. It is called ethene. It is represented as CH2 double bond CH2, where you can find the double bond. So this is called carbon-carbon double covalent bond. Okay, and precisely that is, it is one bond is sigma, another is pi bond. It's called sigma bond, pi bond. Okay, sigma bond that leads to axial overlapping. If the orbital is like this, now another orbital they combine like this, so they form what? A sigma bond. Suppose if the orbital p orbital combine sidewise, that is lateral overlapping, so they lead to what? The pi bond. It will be something like a dog bone. Okay, so this is known as pi bond. So in a double bond, there will be one sigma bond and one pi bond. You understand? So sigma bond is due to axial overlapping, linear overlapping. Pi bond is due to sidewise overlapping of orbital. So we have CH2 double bond CH2. And then in the case of nitrogen, you can have triple bond. So it means one sigma bond. In a triple bond, there will be one sigma bond, two pi bond. Okay, so nitrogen, nitrogen. So we simply write N2, but its structure is N triple bond N. And similarly, ethane is represented as CH triple bond CH. Okay, it has got a linear structure, so you can write like this: C triple bond CH. And you can also ensure the valence of carbon is 4. This is 1 plus 3, 4, 1 plus 3, 4. So the valence is also satisfied. And this is known as another double bond here. So you can count the number of carbon atoms: 1, 2, 3. 3 means a propene, because double bond is present, so it is called propene. So this is known as propene. And in this propene, how many CH bonds are there? 1, 2, 1, 2, 3, 4, 5, 6, 7. So there are 6 CH single covalent bond. And you can identify as one CC bond, then one CC double bond. So this is represented like this. Okay.